Welcome to today's explainer. Look, we are diving into what is honestly one of the most radical, foundational shifts in the modern tech landscape right now. For decades, the memory semiconductor industry was, well, notoriously volatile, right? It was a wild roller coaster of massive booms followed by brutal, punishing busts. But that old world, it's over. We're going to dive deep into the source material today to show you exactly how AI has permanently broken that old cycle, transforming the memory market into a continuous structural supercycle. Okay, let's get right into it. To really understand this shift, here is our roadmap for today. Number 1, the death of the silicon cycle. Number 2, the new B2B demand engine. Number 3, the HBM die penalty. Number 4, why supply just can't catch up. And finally, number 5, the structural growth era. All right, Section 1, Death of the Silicon Cycle. Let's talk about moving away from the past. Historically, the whole memory market was completely dependent on everyday consumers buying PCs and mobile phones. It was what we call a push market. Manufacturers would just churn out a massive amount of standardized chips, throw them into inventory, and basically cross their fingers, hoping the consumer economy was strong enough to absorb them, and that created extreme price volatility. Today, though, that vulnerability to the B2C market has been completely replaced. We're now living in a world of planned, long-term B2B strategic contracts. We're not relying on the unpredictable whims of millions of everyday consumers anymore. Instead, you have just 4 massive big tech hyperscalers, Microsoft, Google, Meta, and Amazon, and they're driving roughly $230 billion, which is about 310 trillion Korean won, in annual capital expenditure. Think of these giants as a massive firewall protecting against traditional market volatility. Because they plan their data centers literally years in advance, their demand provides a structural downward rigidity to prices. Because of this massive firewall, the jagged consumer boom and bust has completely flattened out. We have officially entered the memory wall era. Generative AI has made memory the absolute priority bottleneck resource. It is no longer just some cheap, consumable component you slap into a PC. It's the fundamental constraint on how fast an AI accelerator can compute. And that reality pulls the entire industry out of that old, volatile wave and marches it up a staircase of custom, pre-ordered structural growth. Moving on to Section 2, the new B2B demand engine. Let's look at this unstoppable new demand. So where is all this coming from? Well, it's a complete diversification of high-end workloads. First off, obviously, you have NVIDIA-led AI computing, where the absolute explosion of AI inference requires massive, literally massive amounts of memory just to function. Then we have the evolution of interfaces like CXL and LPCAMM2, and these allow systems to pool and manage memory much more efficiently. And looking just slightly over the horizon, we've got entirely new device categories coming online. Think Level 4 autonomous vehicles and humanoid robotics. In total, there are actually 7 distinct engines driving this structural growth. The big takeaway here is just how incredibly diverse this demand has become. We are not relying on just one single product to hold the market up anymore. To put this in perspective, L4 autonomous vehicles and humanoid robotics don't just need a tiny bit of memory. They demand a staggering 128 to 512 gigabytes per single unit. This effectively disperses the risk. So even if one specific sector slows down a little bit, the baseline structural demand remains incredibly strong. And because this memory is so highly customized for AI, we're entering what's called the new LTA, or long-term agreement paradigm. This is a real game changer. Hyperscalers are now injecting billions of dollars in upfront prepayments just to secure production lines. They are essentially sharing the manufacturer's capital expenditure risk. And it gets better. These contracts come with strict take-or-pay clauses. If a tech giant's demand shifts, doesn't matter. They still have to take the chips or pay a severe penalty. For the memory manufacturer, inventory risk is just completely wiped out. Which brings us to Section 3, the HBM die penalty. Let's talk about the physical limits of AI chips. To really grasp the supply crunch we're seeing, we have to define something called the die penalty. Simply put, high bandwidth memory, or HBM, which is the ultra-fast memory making all this AI possible, requires significantly more physical space on a silicon wafer than standard memory. It is a hard structural cap on growth, and you literally cannot just buy your way out of it. Producing a single unit of HBM consumes roughly 2.8 to 3.1 the physical wafer space of standard DDR5 memory. Because of this massive spatial tax, all this wasted space required for large control circuits, the overall factory output essentially collapses. Historically, the memory industry enjoyed a natural organic bit growth of about 35 to 40% year over year. But today, because so much factory floor space is being eaten up by HBM, that total bit growth has plummeted to just 14 to 16%. And here is why this is absolutely crucial for the broader market: the profitability reversal. Manufacturers are rapidly shifting their production pipelines to meet the high-paying demand for HBM. But because of that die penalty we just talked about, this aggressively cannibalizes standard DRAM factory capacity. It creates an artificial supply choke on legacy wafers. So what happens when standard DRAM supply drops, but normal everyday computing demand stays flat? Prices absolutely spike. Manufacturers end up with a dual-engine profitability reversal. They earn ultra premiums on HBM, while also reaping wildly inflated margins on their legacy DRAM. Next up, Section 4, Why Supply Can't Catch Up. Let's look at the delay in production. Now, you might be wondering, if demand is so crazy high, why don't companies just build more factories instantly? Well, the answer comes down to this number: 2 to 3 years. Capital investment doesn't magically turn into silicone overnight. There's a massive, completely unavoidable time lag between spending the money and actually holding a finished chip. Even though we are seeing unprecedented capital expenditure announcements, you can't just pour cash into a funnel and get immediate bit growth out the other end. First, you've got the die penalty squeezing the volume. Then you have that 2 to 3 year delay. It takes an incredibly long time just to order the equipment, install it, optimize the chemical chambers, and actually ramp up the facility. So simply dumping money into this problem won't create an overnight oversupply. Physical reality just won't allow it. And beyond the factory floor itself, manufacturers are facing incredible external reality checks. The biggest one? Power grid shortages. Data center power consumption is doubling right now, vastly outpacing the physical expansion of our power grids. Currently, the lead time just to get a high-voltage transformer is stretching up to 4 entire years. Think about that. You can have all the AI chips in the world, but if you don't have the electrical substation to power your data center, your capacity is effectively capped. Furthermore, the manufacturing process itself is getting terrifyingly difficult. Take a look at the mathematical reality of the upcoming HBM4 architecture. It requires stacking 16 individual layers of memory. Now, even if your manufacturing is so flawless that each individual layer has a 95% success rate, when you bond 16 of them together, that error rate compounds. 0.95 to the 16th power equals roughly 44%. Squeezing physical limits under 30 micrometers means final packaging yields could hover around just 44%. More than half the materials could end up in the scrap heap, further throttling the actual supply hitting the market. Finally, Section 5, the structural growth era. Let's bring all of this together. When we map out everything we've just covered, we really see the solid foundation of this structural supercycle. We've got big tech completely dominating demand, shifting us away from those volatile consumer cycles. We have incredible new AI and autonomous workloads driving new needs. We have foundry-like lock-ins with 100% pre-orders protecting revenue. And fundamentally, we have the die penalty and strict CapEx lags structurally throttling the overall supply. Memory is no longer a vulnerability, it's a locked-in, custom-built specialty resource. We are fully leaving behind the jagged, volatile silicon cycle of the past. Driven by these custom pre-orders, massive physical capital barriers, and just relentless AI demand, historical volatility is dampening. We're now transitioning onto a smooth, upward structural growth trajectory heading straight into 2030, what we called the high-margin plateau. The commodity era as we knew it is officially over. So I want to leave you with this thought. As you look at the tech landscape today, are your current mental models still relying on that dead volatile silicon cycle, or are you prepared for the locked-in realities of the structural supercycle? The shift from B2C to B2B, the rise of AI interfaces, and the absolute physical limits of the die penalty have completely rewritten the rules. It is absolutely time to rethink the market. Thanks so much for joining me on this explainer, and I really hope this sparks some deep curiosity about the future of our digital infrastructure.